Reinforced concrete beam load calculation example 1. In this example, we do have a rectangular cross section with a tensile rebar at the bottom section, which is a two simple support beam with a span length of 10 feet, handling a concentrated live load at its center, which we are looking for the amount of this force, and a dead load, a uniformly distributed dead load over the span by the amount of 5 pound feet. So in this example, we want to calculate the based off of the moment capacity, we want to calculate the maximum acceptable live load which can apply as a concentrated load at the center of our beam. If we do know that F prime C is equal to 3000 pound square inches and yield stress of a steel is 40,000 pound inches square, and AS, which is the area of our tensile rebar, is a 3 inches squared. Let's solve the problem. So first of all, we do know mu ultimate moment is equal to a coefficient of a so that because we are going to solve it based on the moment capacity, so that's a combination of dead moment plus live moment. So again, that's a 1.2 dead moment plus 1.6 live moment, like loads. So in that case, we do need to calculate the moment for each of those part. For example, for a first, let's go with a distributed dead load of 5 pound over feet. So if you draw the shear, it's like this, and if you draw the moment, it just give you the maximum moment. It's WL squared over 8, and that's 5 times length squared over 8, and that gives us 62.5 pound feet. If we do the same process for a concentrated load, which the force is itself unknown, and we are going to solve it. So this is the shear stress. So it just goes by the amount of support. Whatever P is, it just goes up by P over 2 all the way. It drops down by the amount of P, go all the way and climb up to a P over 2 to reach 0. And if you calculate the moment maximum, M is P, a quarter of P times L. So if we replace that in the formula of mu, so mu is again 1.2 md plus a 1.6 moment life, and if you replace that, it just gives you 1.2 times 62.5, which we already calculated, plus 1.6 times p times a 10 times 4. That's the moment which we calculate, but we don't know what the a numeric value of p is. So M ultimate moment is 75 plus 4 times P. And at the same time, we do know ultimate moment is a reduction coefficient for tensile member times a nominal moment, and that's a for under reinforced condition, and a phi for tensile member, that's 0.9, 90% of nominal moment. And if you remember again the a Whitney equivalent stress distribution, and in order to in balance condition, it just gives us a summation of force, gives us the depth of the Whitney's block, which is A. Hmm. So if you solve this equation in x direction, and it just gives us A is equal to AS times Fy over 85% F prime C times the B other dimensions of the cross section. So again, mu ultimate moment is a reduction factor in tensile member times nominal or resistant moment. They are identical to each other. We call them both of them. And it just, if you equivalent x forces with each other, it just gives you A is equal to the height of equivalent block is area of steel times yield stress of steel over 85% of specific strength of concrete times a dimension b to the board. And if you replace the numeric value based off problem statement, it just gives us a is equal to height of the witness block is equal to almost 4 inches, and that's a 3.92. So Mn or Mr nominal moment or resistant moment is then 85% of prime CAB times D minus A2, again based off the Whitney stress distribution consideration. And if you just replace A from here, which you calculate to the main formula of a nominal moment, so it just gives us nominal moment of resistant moment, they are identical to each other, is equal to this equation. And if you solve it, it just gives you a 1564.70, almost 10 to 10 cubed, and mu, which is 90% of that. There is a reduction factor here, and it just gives you a ultimate moment of this amount in terms of pound inches. So if mu is this amount in terms of pound inch, and we want to just convert it to a pound feet, you just simply, each 12 inches is 1 feet, so divide it simply by 12, and it gives you a 117 point, almost a 3 times 10 cube pound feet. Mhm. And at the same time, mu is equal to this equation, which we replace that, and it just gives us mx is equal to 75 plus 4 phi. This is mx, m ultimate, this is m ultimate. If we call this equation 1 and the other equation 2, 1 and 2, it just says 75 plus 4 times p is equal to 117.310 cubed. And if you solve this equation based off p, it just gives you a p is consider live load of p live is equal to 29,000 pounds. Thank you. We'll review more problems in this topic.